Hey guys, so in this video, we're going to discuss Leetcode 2158, which is a very common question asked in Google interviews. So in this problem, we're going to be given a 2D array, and every item in the array has two values, the start position and end position. So the ith item in the array means the painting areas for the ith day with the start and end value. And also for the same area, it can only be painted once, and it will be painted by the earliest date. So let's look at example one. So the input means like on day 0, I paint areas from 1 to 4. And on day 1, I paint areas from 4 to 8. And on day 3, I paint areas from 5 to 8. So day 0, I paint 3 areas. And at day 1, I paint 3 areas as well. But on day 3, I only paint 1 areas because for area 5 to 7, it's already covered by a previous day. So that's why on day 3, I only need to paint 1 new area. So the naive approach to solve this problem is to use a nested array. Like I loop for every item in the input array, I just loop through all the previous items and check the overlaps with them. This will have a time complexity of n squared. So let's try to improve that with a better time complexity. So the most tricky part for this problem is like for every area, it's gonna only paint one time and it will only be covered by the earliest date. So what we can do is like we can loop through the areas in the areas in the input. Like in example one, we have painting areas like the in total painting areas will be from 1 to 8, right? So at position 1, we only have day 0 because only day 0 available, right? So position 1 will only be painted by day 0. And the same for position 2, it will be painted by day 0 as well. And for position 3, they're going to be painted by day 0 as well. And the position 4, day 0 going to be removed, right? Day 0 is not available, it will be ended. And then day 1 will be starting. So position 4 will be painted by day 1. And the position 5, day 1 is still here, but day 2 already will start painting again. We're gonna have day 2 in the array. However, we only care about day 1, which is the smallest value. So we're gonna although we have 2 days available for this date, but for this painting area, but we only care about the smallest one, which is day 1. So that's why for position 5 is still day 1. And the position 6 is day 1 as well for the same reason. And the position 7 for day 1 as well for the same reason. But on this day, after this day, day 1 will be removed. So we're gonna remove day 1 and we'll only have day 2 available. So position 7 to 8 will be painted by day 2. And on day 8, day 2 will be removed from the available dates. So it will be removed, and then we have an empty available date. We have no available dates anymore. So so we're gonna keep a data structure to store the available days for every area, right? But for the available days, we only care about the smallest value. So that because the smallest value will be used for that painting area. So that reminds me of the data structure of heap queue. Because for heap queue, we only care about we can get the smallest value easily, and we don't care about the values beyond the smallest value. So what we can do is like we can have a heap queue to store the available dates for every area. And then we just adding days and removing days from the available days, the heap queue of the available days. So yeah, so that's the main algorithm we're gonna use the heap queue to for every area we gonna just loop through all the areas we're gonna paint, and for every area as we move through the areas we're gonna just keep track of the days available for each area for the current area, and then just get the smallest value for the available days, and that will be the date for the for that area. So yeah, so heap queue is the algorithm data structure to use. So let's start coding. So yeah, so of course I'm gonna need a heap queue to keep track of the days. So this will be a heap queue. So I can just gonna initialize it with an empty array. This will mean this will be the available days for the area. It will be a heap queue. And then I can also need to, so since I need to loop through the areas like in order, So I'm gonna sort the input list. So what I'm gonna do is, and I also gonna need to keep track of the available days and the ending days, right? So what I'm gonna do is like for every item in the array, I'm gonna split into two items, like position, the date, and also the type. Either it's the starting of the day, or it's the ending of the, or it's the starting of the day or the ending of the day. So what I'm gonna do is like I'm gonna have a records array, which we're gonna keep a records of the paintings. So I'm gonna just reformat the input data. So for the day and the paint in enumerate of the paint. So I just loop through the paint, and so for every the start and will be I get a start and end positions. So for every paint in the paint array, I'm gonna do records dot end. So it will have the position and the date and the 0. So 0 means it's the starting type of the record, and then I also gonna have the end, and this one I'm gonna have it 1. So 0 means it's a starting of the day, and 1 means the end of the day. So every item will be position, day, and the type. It will be 0 for start and the 1 for end. So once I'm gonna loop through the record. Every time I see the type is 0, I know this will be the starting of the day. And every time I see the 1, I know this will be the ending of the day. So for starting of the day, I'm gonna push the day into the available days heap queue. And for end of the day, I just gonna remove the date from the available days heap queue. All right. So then I just gonna sort the records so that I can process every position in order. All right, so now I'm gonna just loop through the records for position, day, and type. So type is a reserved word in Python, so let's just use T in records. All right. So what I need to do is like, if I have days, right? If there are days available, then the days 0 will always be the paint day, because days is a heap queue. Paint day would be day 0, days 0, and then for that paint day, I need a response. So this will be the return data. I just initialize it with the zeros. So for that paint day, I just increment the painting area. Okay, so I need a start position. This means the last position I painted for that day. So it will just be position minus last position. All right. And then I just need to update the last position. So this will be the new last position. The current position will be the new last position. And also, if t equal to 0, right? So if type is 0, I need to push the day into the available days. Otherwise, I need to pop it out. So in order to pop it out from the heap queue for the day, it will be So to pop it out, because I only in the heap queue I only keep track of the I only know the early state in the heap queue, right? So for pop it out, it might be tricky. So what I can do is like I can keep a record of the finished days. Give me a second. So Let me just keep a record of the finished days. Finished days and make it a set. So I can just add it into the finished days. So that will be time complexity of order of 1. And in here, every loop, I just gonna firstly pop out all the days that have been finished, right? So what I can do is like if I have days, right? So I just gonna first pop out. What I can do is I can keep. So if days 0, that will be early state, right? In finished days. So while days 0 in finished days, I just heap queue, just pop it up, heap queue dot heap pop the days. All right. Yeah, when I pop while days end, so every time I pop it out, I need to check if days like if I only have day 1 in the array and then I pop it out and then in the while loop it's gonna error out because days doesn't have it's an empty array. I cannot do this, right? So yeah, I can remove the if in this case. So while I have days, and then the day is already finished, then I just pop it out. And now if days, so if I still have days available, then which means this area going to be painted by the earliest date. So pen date will be the day 0, and the pen date will increment by the areas being painted. And then I overwrite the last position to the current position. So which means this will be the new starting position that can be painted by the next day. And then if it's a starting type of the date, then I just push it into the days available. Otherwise, I just gonna mark it as already finished. So and then it can be popped out in the next loop. Okay, so let me just return the output. Let's see how it goes. Yeah, it looks good. So for time complexity, although like it looks like it's a nested loop here, like it's a while loop inside a for loop, but the tricky part is like for the heap queue, right? Heap queue, the worst case is like every day is in the heap queue for one time. Oh, for two time, like yeah, for one time actually. We just insert every day in the heap queue, right, and then pop it out. So although it looks like it's a nested loop, but the time complexity will still be n log n because like we are just adding every day into the heap queue and then popping them out. So it's n log n. So yeah, so total time complexity will be n log n, and the space complexity will be O of n for for these arrays. All right, so this is the end of the video, and I'll see you guys in the next one.